Good morning, 8th grade. Today, we're going to talk about electrons, and we're going to talk about what they have to do with whether or not an element is reactive. Let's get into it. So we determine whether or not an element is reactive based on what that element has in its valence shell of electrons. So first we need to know, well, what is a valence electron? Valence electrons are on the outermost orbits of the atom. So we know that atoms, again, they have protons and neutrons in the center, and electrons orbit around sort of like planets orbit around the sun. And the valence electrons are just these ones on the outside. So these outside electrons matter because these are the ones that are going to chemically react with other elements. So the periodic table is actually organized by this property, which is called electronegativity. So the more electronegative something is, the more likely it is going to react with another element. So for example, electronegativity increases as you go up the periodic table. So for example, sodium is more electronegative than calcium. And also it increases as you go from the left to the right. So beryllium is less electronegative than nitrogen. And what that means is that nitrogen is just going to be more likely, a little bit more likely to react than beryllium. Or lithium is highly reactive because it's here at the top. It's very electronegative and it's more likely to react with another element than cesium, which is down here. So go ahead and pause this video and open up to page 385 in your book. I'll wait. Okay, so on page 385, you have this table that gives you some instructions for figuring out how many electrons are in the valence shell of that atom. So the first thing you do is you identify the element's group number on the periodic table. If you look at beryllium, beryllium is in group number 2. So actually, that's really easy. Beryllium has 2 valence electrons because it's in group number 2. Don't worry about drawing electron dot diagrams today. We're going to worry about that next week. The fact that it has 2 electrons in its valence shell makes it chemically unstable. That's because a valence shell can have up to 8 electrons in it. So if there's any spaces missing, we will call that chemically unstable. And the number of bonds that this atom can form is the same as the number of bonds that there are electrons in the valence shell. So it gets a little different when we go further down the periodic table. The group numbers become double digits, and we just pay attention to that last digit. So for example, carbon is in group 14. That means it has 4 valence electrons. It's chemically unstable because 4 is less than 8. And so it can form 4 bonds. So I want you to really review page 385 in your book. That's going to help you answer the questions on your Google Forms quiz today. Chemically stable elements are elements where they have full valence shells. So that means they have a full 8. So noble gases are chemically stable because they have a full 8 valence electrons. And you can see that in that table on page 385 of your book. Now there are some that are a little bit weird. For example, helium, it only has 2 valence electrons, but that's because that first valence level can only fit 2. I'm not going to give you any weird exceptions to the rules today. We'll talk more about those next week. If you have any questions on this, email me, text me, send me a message via Google Hangouts. Otherwise, go ahead and get back onto the blog and take your Google Forms quiz for today. Have a great Friday, guys.